So in this video we'll be going through everyone's favourite topic in maths, fractions, with a focus on being able to multiply them together. So multiplying fractions are a lot easier than adding and subtracting, as there is no need to get a common denominator and there is a set method on how we multiply fractions together. So multiplying, the general method of multiplying two fractions together, so we're not going to be looking at mixed numbers or a mixture of fractions and whole numbers, that will be discussed later, is to simply multiply the two numerators or the two top numbers together and to create a new numerator, and multiply the two denominators, in other words the two bottom numbers, together to create a new denominator, and then finally simplify the answer if possible. Now for your note purposes I certainly would recommend doing this, and if you're not comfortable with algebra, do not worry. So this is the general method of multiplying. So in other words, what we do is we multiply the two top numbers together, multiply the two bottom numbers together, where A, B, C and D are numbers. Now this method only applies to multiplying single fractions together and will always work regardless of what the numbers A, B, C and D are. However, to make your life easier, it is always best to check to see if you can simplify the fractions before you can multiply them together. This will save you from multiplying big numbers together, hence therefore saving your time, and having to simplify at the very end. The key thing to note when simplifying multiplying fractions is that you can use any numerator and any denominator, so it just doesn't have to just be on one single fraction. And again, this only applies when you're multiplying fractions, and if none of that made sense, do not worry. When we go through some examples, hopefully it will do. So let's have a look at these examples. Now when you're doing some quite simple and small number multiplication with fractions, there are little things that you kind of need to be able to do. Now the longer you write, the more you write down, the longer it could take, and the more you can do mentally, the quicker it's going to be. However, you do not want to sort of sacrifice time with accuracy, especially in maths. So first of all, let's have a look at question 1. And let's do a different colour. So with question 1, we've got 2/5 times 3/7. So here what we want to do is, the first thing you want to do is ask yourself, can I simplify any of the fractions? So I can't simplify 2/5 and I can't simplify 3/7. Now the additional thing, which we do also need to look at, is can I simplify 3/5? And can I simplify 2/7? Because you don't have to simplify the numerator with its respective denominator. I can use the other fractions denominator and I can use the other fractions numerator when it comes to simplifying. Now in this I can't do any further simplifying, so what I'm going to have to do is use the formula. So here what I'm going to do is multiply the two numerators together, so that's 2 times 3, and I need to do 5 times 7. Now you don't always have to write this down, and there'll be no expectation for you to write this down. So what you could do, and depending on how confident you are with multiplying, is do what I've written in the sort of green bubble in your head. So here, and you might find it's a lot quicker. So 2 times 3 is 6, and 5 times 7 is 35. And then all you then need to do is ask yourself, well, can I simplify this fraction? The answer is no, so there is your final answer. So let's have a look at question 2. So question 2, we've got 4/5 times 3/10. So again, we ask ourselves, can we simplify the single fraction? So I can't simplify 4/5, I can't simplify 3/10. However, one thing I can do, and if I get a different highlighter, let's go for yellow, I can simplify 4/10. Now, multiplying numbers that are less than 10 should be relatively bread and butter to you. So you don't have to go through this stage. So if I, let's say, ignored the simplifying and just did 4 times 3, which is 12, and 5 times 10, which is 50, I then get 12 over 50, which I can simplify because I can divide both numbers by 2. So I get 6 over 25, and there is my final answer. Now if I recognise that 4/10 can be simplified, so let's just get a different colour, and let's say I divided both these two numbers by 2, then what I'll be working out is 2 times 3, which is 6, and 5 times 5, which is 25. And you can see by simplifying the question, I get to the final simplified answer a lot quicker. So it doesn't really matter how you do it, as long as you unit correctly. And sometimes if you're happy and comfortable with multiplying with big numbers, you might think to yourself, do you know what, I'll simplify at the end. If you're not so great at multiplying big numbers, then you might want to consider seeing if you can simplify at the very start. So with example 3, we've got 10 over 12 times 7 over 8. Now if I go through this without simplifying at the start, we have 10 times 7, which is 70, and 12 times 8, which is 96. And if I simplify that, because they're both even, so I can simplify that first, so let's divide both numbers by 2. I get 35 over 48, and that cannot be simplified any further, so that there is my final answer. Now if I simplified at the start and recognise, well, okay, 10, I can simplify this fraction, which that then gives me 5 over 6 times 7 over 8, then went on to multiply, I would get to the answer a lot quicker. Now I can also, if I had 10, let's try doing this in a different colour, another way of simplifying this fraction. So let's say we had 10 over 12 times 7 over 8. Now I can use this and see if these two simplify, what they do. So I can divide both these two numbers by 2, so I get 10 over 5 and change that to a 4. So if I do 5 times 7, that's 35, and 12 times 4, which is 48. You can see that there's several ways in which how I can get the final answer of 35 over 48. So it all depends on whatever you see and whatever you feel comfortable with. If you feel comfortable with multiplying big numbers, you can do the simplifying at the end. If you don't feel comfortable multiplying big numbers, you can do the simplifying at the start of a question. So it really does depend on how you are feeling. And it all depends on how you're doing as well. So sometimes you might see the fact that it simplifies and sometimes you won't. It all really depends, like I said, on how you first read the question and what you can actually spot. So let's just quickly go through the other sort of 5 questions, and let's have a go. So we're on question 4. So with question 4, we've got 2 6 and 9 12. So let's just quickly write that down. So again, I can simplify the 6 and the 9, so because they both go into 3, so that becomes 2 and 3. And then multiply 2 times 2, which is 4, 3 times 11, which is 33, and there is my final answer. Now again, if I did 2 times 6, which was the original, which gives me 12, 9 times 11, which gives me 99, I could then simplify the answer, in which I get the same 4 over 33. So as I said, whichever floats your boat. So with question 5, I've got 3 over 8 times 7 over 12. And again, I'm going to have 21 over 96. And so from this, I can then go on, so 96 it should be. And then from this, what I can then do is simplify this further and go on from there. So I can divide both numbers by 3. So I get 7 over 32, and there is my final answer. And again, if you wanted to simplify sooner rather than later, I can simplify, let's write it again so I'm not go from there. So I could simplify the 3 and the 12 by dividing both numbers by 3, in which I get 1 times 7, which is 7, and 8 times 4, which is 32, and again gives me the exact same answer. With question 6, I've got 6 over 12 times 3 over 8. So again, I can simplify this fraction as to 1 over 2. So I've got 1 times 3, which is 3, 2 times 8, which is 16, and there is your final answer. With question 7, I've got 5 over 11 times 3 over 5. Now I can simplify the 5 and the 5, which gives me 1, 1. So I'm doing 3 times 1, which is 3, 11 times 1, which is 11. There's the final answer. But again, if I chose not to simplify at the start, I'd have 5 times 3, which is 15, 11 times 5, which is 55, and then simplifying 15 and 55, divide both numbers by 5, I get 3 and 11. So like I said, whatever you prefer, simplifying at the start or the end, as long as you're doing it correctly, you always end up with the right answer. And finally, 21 over 100 times 2 over 50. So again, that becomes, let's not simplify. So I've got 42 over 5,000, and then divide both numbers by 2, I get 21 over 2,500, and that won't simplify any further, so there we go. But again, if I did choose to simplify, well, I can halve both those two numbers by 2, so I get 1 and 50. Oh, let's get rid of that little squiggle. And so we've got 25 over 50, so then I'm going to do 50 times 50, which is 2,500, and 21 times 1, which is 21, and there is your final answer. So hopefully that makes a little bit of sense. We did spend a little bit of extra time working on this because it is such an important step. So let's have a look at what happens when we have a fraction, when we multiply a fraction by a whole number. So when we're multiplying a fraction by a whole number, we simply convert the whole number into a fraction by having it over 1 and then repeating the previous method. So for example, what we've got here, so we're using green, so here we've got a quarter times 2, or 1 over 4 times 2. So what I'm going to do is I'm going to convert that as 2 over 1. So so now question 1 will read a quarter times 2 over 1. So then I'm going to do 1 times 2, which is 2, 4 times 1, which is 4, and again remember that we then need to simplify this, which then becomes a half. With question 2, again I'm going to have this over 1, so with question 2 I've got 1/5 times 3 over 1. So I've got 1 times 3, which is 3, 5 times 1, which is 5, and there's the final answer. With question 3, again, convert that into a 1. So I've got 3 over 1 times 7 over 9. And again, this one is going to involve some simplifying. So again, you can simplify at the start or the end. I'm going to leave it because multiplying any single digits is going to be relatively quite standard. So I've got 3 times 7, which is 21, 9 times 1, which is 9, which then divide both numbers by 3, which gives me 7 over 3. Now this, because it's an improper fraction, I can write that as a mixed number, so that's going to give me 2 and 1/3. Now if you have absolutely no idea what I'm talking about there is a video on how to work with mixed numbers with improper fractions on another video, which I recommend that you do watch and like. So anyway, going back to question 4, I'm going to write 8 as 8 over 1, so I've got 8 over 1 times 3 over 12. 3 times 8 is 24, 1 times 12, which is 12. 24 over 12 gives me an answer of 2, and there is your final answer. So here we can then move on to our next type of multiplying with fractions, what happens when you're multiplying two mixed numbers together. Now if you're multiplying involving a mixed number, you must, and this is the most important step and it's definitely worth highlighting, you must convert any mixed numbers into improper fractions. Now again, as mentioned literally 10 seconds ago, if you're not sure how to do this, there is another video on telling you how to do this, but I'll quickly explain on terms of what I'm doing with this as I go on. So with question 1, we've got 2 1/4 times 3 1/2, so what I'm going to do is convert this into an improper fraction. So how we do this is we multiply, well, the denominator is going to stay the same. So I'm going to do 2, the big number times the bottom number, which is 2 times 4, which is 8, and I'm going to add it to the top number, which gives me 9. And that's going to be times, or multiply I should say. And again I'm going to convert this mixed number 3 1/2 into a mixed number, so I'm going to do so again it's going to be over 2, because the denominator always stays the same. So 3 times 2, which is 6, plus 1, which is 7. And again, now I've got them both as single fractions. I'm now going to multiply the two numerators together, multiply the two denominators together. Now again, check to see if you can simplify, which in this case we can't. So I'm going to do 9 times 7, which is 63, and 4 times 2, which is 8. And again here, I'm going to write this as a mixed number, which gives me how many 8's going to 63, that's going to be 7. The remainder is 7, and we're dividing by 8, so the answer then is 7 and 7/8. Now with question 2, again what we need to do is convert any mixed numbers into improper fractions. So 2 3/4 is going to be something over 4, so it's going to be 4 times 2, which is 8, plus 2, plus 3 rather, is 11, times, and then again I'm going to convert 6 and 2/3 into a mixed number, so that's going to be over 3. So I've got 6 times 3, which is 18, plus 2, which is 20. Now again, because I'm dealing with quite big numbers, one thing I've spotted straight away is that I can simplify 20 and 4. So I can divide both those two numbers by 4. So you could divide by 2, but I'm going to go for 4's bigger. So how many 4's going to 20? That's 5. How many 4's going to 4? That's going to be 1. So now, rather than doing 11 times 20 and 4 times 3, I'm now going to do 11 times 5, which is 55, and 3 times 1, which is 3. And because again that's an improper fraction, I can see how many 3's go into 55. So how many 3's go into 55? Well, that's going to be 18, my memory serves me correctly, and with a remainder of 1, and I'm dividing by 3, and there is our final answer. So again, if you're wanting any practice of these three sort of aspects of multiplying with fractions, I'll attach a worksheet in the description along with their answers.